You went to Austin again?
No, I'm not going to Austin.
Go to Austin again, hang out with us.
No,
There's a really good restaurant in Austin we wanna try. Well, my friend told me to go.
you guys go to Austin.
Just go carpool.
Huh?
Just carpool.
1 hour
Fun. You said it. You said working from home, you don't get to feedback. Time to go hang out in Austin.
Well, like,
You get to feedback.
anything in Austin, that's like starving, man.
We went there too late last night. We were around 5. This time we have to be there around 9 or 10.
Before 2 weeks.
You're arriving there early and just hanging out.
Let us continue to discuss
Okay, you guys have fun. It's all you guys, right? So.
second element is power.
He will take 1 class.
Thyristor. Power thyristor. Same the diode, but provided by control from the gate. This anode, this cathode. The current will flow from anode to cathode. The current flow from anode to cathode, IA. The relation between IA and VAC, V anode, cathode. See, in the forward bias. The forward bias, and the diode forward bias will be on. Okay, the forward bias, the diode here is on. But for thyristor, no. When I get gate current or V gate to be on with the forward. So when the diode is forward, still off, so the current is small value, and when the gate triggered by any method, by voltage, by current, will behave as diode, same the diode, same the characteristic of the diode. But in this time, no, it's forward but off. So this case is forward but off state. And this is forward on state. On state. And in the reverse bias, same the diode, V zener, IS, this is reverse. Or off state. We have forward off state, forward on state, forward on state, forward off state. Why off state? forward but offset because no trigger at the gate to turn it on. So, but when the gate triggered by any current or voltage, the diode characteristic similar to the thyristor characteristic is exponential. Okay, this is exponential. But in forward is low current less than saturation current in microampere, but forward, but still off state. But when the thyristor triggered by current, by the voltage, okay? So at this voltage, this is called V halt, and the current is called I halt, and this IL, where IH holding current, IL latching current, latching current. So holding current and latching current. I latch more than I hold, around 1.5 to 2 times. IL equal 1.5 to 2 times of I hold. From 1.5 to 2 times of I hold. Any question, please, on this one? This is the power electronic device. Okay, no electronic, we use the power electronics converter as inverter, DC to DC converter, rectifier, control rectifier. So this is very important device. Thyristor, okay, this is very important device. Power thyristor, semiconductor control rectifier, but it's general, not rectifier. General, we can use it in the control rectifier, in the inverter. So thyristor use. Sorry, do you need this page? No? Thyristor. Use in the control rectifiers, inverter, DC to DC converters. Third device is power transistor. Power transistor either NPN or PNP transistor. NPN and PN. PNP display. And the terminals, emitter, base, collector, emitter, base, collector. Where E emitter, B base, C collector. PNP and PN, same analysis, same circuit, equivalent circuit. PNP or NPN. Now the characteristic of this device, PNP or NPN, same is the relation between IC, corrected collector current, and VCE. VCE, voltage between collector and emitter. Okay, where, as example, this is collector, this I collector. This base, this is I base. Okay? Collector, emitter, this is emitter. Or sometimes IC, same IP, or depend on the type of connection. So I emitter equal I collector plus IB. I emitter equal I collector plus IB. So IC plus IB equal IB. The characteristic between IC and VCE, this is VCE. This VCE is given as this one for IB naught, increase IB naught, IB1, IB2, IB3, IB4. Okay. This is the characteristic. Now, there are 4 regions for this operation. 3 is very important. Very important. This region, this one, this area, this is saturation. Region. cutoff region of state and this region is active. Active region.
So the current in the saturation region is very small,
The current in the saturation, no, very high.
very high.
But the voltage VCE is very small. But the current in the cutoff region, cutoff, off, open, the current will be small. And the voltage, the open circuit should be high. Okay. This active region, okay, and see for the diode thyristor or transistor in power electronics, all of them working as on-off switch. This on and this off. See, in this class we will work on the on-off. That's it. Not in the active region. No need to amplify the signal. Okay? I saw one paper, two papers in the net and published in good receiver, okay, good journal. DC to DC converter efficiency, DC to DC converter amplification. No amplification, no need to any amplifier or amplification in the DC to DC. Just a switch on off. Next week we'll discuss DC to DC converter. See, it's just DC to DC, just a switch. Switch on, switch off. That's it. No need to amplify amplification and everything in the electronic field, no in the power electronic. In power electronic, all devices working as a switch on off. Control or not control, control same the transistor or thyristor control devices, but uncontrolled diode, uncontrolled. Just forward voltage on, reverse voltage off, but this is controlled by I base. Thyristor controlled by I gate. Any question, please? Okay. Field effect transistor, FET. Field effect transistor, field effect transistor. Also is power field effect transistor. What do you mean by power thyristor, power transistor, power diode? Why we say power?
It affect the power of like it convert the power.
No. This is power transistor. Why power transistor? Power transistor because the rating of the transistor high. The voltage rating across it is very high, reach to 600 volt or 1 kilovolt. the current follow and sorry, the current flow and RMS and average high reach maybe 1 kiloampere or 100 kiloampere current flow. Okay? Current. So called power, high or high current, high power, high voltage, high. Okay. While the transistor is electronic transistor, maybe the applied voltage just 5 volt DC or 20 volts AC. The current flow in the electronic transistor is very small, maybe maximum 0.5 ampere in milliampere. 0.5 ampere means 500 milliampere. Okay, so current RMS and average flow in the transistor or thyristor or diode or any device in electronic is low light current. Okay, while the power devices no high current, high voltage. Okay, yes. Yes, the material and the size. Yeah, the size of the power transistor is this one, and depend on the rating. Okay, while for the electronics, okay, and the doping and some also same the resistor. The resistor we have power resistor. Power resistor means yeah, high rating power. Okay, can carry out high current, high voltage, but for the 2 watt or 1.5 watt resistor is a small resistor. Okay, this depends on the type of the application. You want to apply the resistor in power circuit, or you want to apply use this resistor in electronic circuit or electric circuit, or okay. And this the value of the resistor. The value of resistor is for power resistor is small, 10 ohm, 100 ohm, while for the electronic 10 kilo ohm. For electric circuit maybe 5 kilo ohm. Okay, but for the power it should be a small value. Why? Because we need more current. More current should be less value of the resistor. Field effect, also power field effect. We have 2 types of field effect. N channel or P channel. N channel is N channel, and P channel is P channel. Simple. And this is a gate, drain, source, gate, drain, source. Okay. For N channel or P channel, same concept. Just reverse the DC biasing. That's it. But the same concept. And for the AC circuit, same. So the AC positive, negative, positive. So for DC, good. So now the relation between ID, this ID, this is ID and VDS, ID and VDS, given by this characteristic, is the characteristic, this characteristic, this one, see here, this region, triode region, or ohmic region. Why it's called ohmic region? Because the relation between the current and voltage is linearly, okay? So the relation between the current and voltage is linear. This is characteristic of the resistor, okay? So it's called triode region or ohmic region. This is saturation. Region or pinch off region. Okay, and this is breakdown. Breakdown region. The design, I will specify the type of the transistor used, the design. Use field effect, use MOSFET, use BJT, okay? BJT. Power transistor is called BJT, bipolar junction transistor. Here, but field effect, BJT, MOSFET, thyristor, same, all of them switch on off, on off. That's it. Any question? Okay. This is field effect on MOSFET. Metal, oxide, semiconductor, field effect transistor. There are two types of MOSFET and channel P channel. And another types of the MOSFET depletion region or enhancement, depend on the threshold voltage. But in our class, we just the MOSFET on off. Enhancement or depletion and type or and channel, P channel, don't need all these details. Okay. We need transistor on or off. So the relation between this is and or this is P N channel or P channel. This is the characteristic between the drain current, this I drain, so this is drain, this gate, this source, the drain, I drain. This is fine, no problem. This one, this one, I drain, drain, this source, this gate, ID, VDS, this characteristic. Okay. And approximately the transistor, BJT transistor, field effect are mostly the same. But all of them we needed the device as on off. That's it, on off. No need to amplify the voltage or amplify the power, or we need the device as switch on off.